Hi everyone, welcome to our session on the 4 things you need to secure a hybrid cloud environment. My name is Muke Gupta. I run product management for our VM series, NCN series, next-gen firewalls. I'm also joined today by Doug Cahill, who is a VP and Group Director of Cybersecurity at ESG. In the next 25 minutes, our goal is to help you understand the key challenges with securing hybrid cloud environments and what do you need to overcome these challenges. But first, let's start with what exactly is a hybrid cloud. Most enterprises today use data centers and multiple public clouds. On top of that, they run workloads. They're all trying to move towards containers and serverless, but most still have plenty of bare metal servers, VMs, and even mainframes. But all that is just infrastructure. What they really care about is the enterprise apps running on top of that infrastructure. These enterprise apps tend to be highly interconnected. Most apps would connect to core services such as Active Directory, administration, logging infrastructure. Many of these apps also connect to critical databases running on Oracle and mainframe systems. And because it's the network that connects these apps, network security has to deal with large, complex networks of interconnected applications hosted on heterogeneous workloads running in multiple public clouds and data centers. And this is what people refer to as the hybrid cloud. So what challenges does that bring to your network security teams? Well, the network security teams are not even involved when the application teams start adopting cloud or containers. Yet they are the ones who own the responsibility of making sure that their enterprise does not show up on the front page of Wall Street Journal for a breach. As the network security teams are not involved, the application teams end up deploying the native network security controls, such as AWS security groups or Kubernetes network policies that are available in these cloud environments. And initially, this might be okay because these environments may not pose as big of a threat to the enterprise. However, as the adoption of containers increases, the containers start connecting to non-containerized critical applications such as Active Directory or the shared databases running on legacy systems. You also start onboarding apps that have high risk and compliance needs. And this is when the network security teams start worrying about the risk that this container environment brings to the enterprise. And they want to secure this environment with the same rigorous security they use to protect the rest of the infrastructure. But then they run into these three challenges. The native security lacks the layer 7 visibility and protection. It provides basic layer 3, layer 4 security, which by itself is not enough to protect these apps from the advanced threats. The second challenge is the lack of consistency. The average organization is experimenting with two, three public clouds and 1 or 2 private clouds. The native security capabilities of these clouds are not just rudimentary, but also totally different from each other. So the network security teams have to learn each one of them and then manage security totally differently for each environment. And that increases the overhead and brings the overall security posture down. So the network security teams, they want to use the advanced security provided by the next-gen firewalls in all environments consistently. And this is when they run into the third challenge. They struggle to find tools that can operate and scale as seamlessly as the cloud infrastructure itself. Otherwise, they end up slowing the application teams down, which defeats the purpose of moving to cloud in the first place. So these are the challenges we see our customers grappling with. Doug, as an analyst, you talk to so many customers. Why don't you jump in right here and tell us your perspective on the adoption of cloud and containers and hybrid cloud and the challenges it's bringing to the network security teams?
Thanks, Mukesh. That is absolutely correct. Our market research really highlights the points that you're making, which is that incremental heterogeneity absolutely drives incremental complexity. And to your point about having silos, we're also finding that in our research, that as new technology arrives and is being consumed, it's typically in a siloed approach where you have separate teams securing separate environments using separate controls, which over the long haul, of course, is untenable. So let's start off by taking a look at some ESG research related to the adoption of application containers. We've absolutely found that application containers have moved from the lab into production. So they are no longer exclusively just a dev and test environment. They are now running production applications. As you can see from our research, for those organizations that are doing internal application development, over 3/4 of the respondents, 76% of the organizations that participated in our study, have or are planning to have application containers run in a production environment. Another 22% are planning to do that shortly. So what's driving the broad adoption of application containers? Well, the big word today is agility. Modern technologies and cloud computing in general allows businesses to simply be more agile, to be able to move faster. And in this context, with respect to containers, we had nearly 40% of the respondents, 37%, who said, hey, you know what? The use of application containers allows us to be significantly ahead of our deployment schedule. That's a huge competitive advantage for organizations to not only meet their deployment schedules, but be able to beat their schedules in today's world of continuous integration and continuous delivery of new features and functions and applications into production. Now, with that said, and again, to the point that Mukesh made up front, we live in a heterogeneous reality. And, very often with new technologies like containers, there's a lot of attention paid to those new technologies, rightfully so. As I mentioned in the prior slide, they provide tremendous business benefits. But with that said, they exist with pre-existing technology. And so our research, shows very, very clearly that today's mix of server types is a heterogeneous one, and it will remain so moving forward. Said another way, application containers are being adopted in addition to other server types, not in lieu of. Now, having been in technology for a number of years, I'm always mindful that old technology doesn't get turned off overnight. It does not get decommissioned right away. Old tech has a long tail. We still have Oracle, running on Solaris. Gosh, we also have mainframes and tape libraries. And so this is the heterogeneous mix of the server stack that we see today that will persist and continue moving forward. What does that mean for all of you? It really means to think about a full stack approach to securing the applications that are running across your hybrid multi-cloud environments. So the other really interesting dynamic about containers is portability. So let me try to connect a few dots here. So Mukesh talked about sort of the complexion of today's modern data center, comprised of on-prem infrastructure, typically multiple public cloud providers in terms of infrastructure and platform as a service, so hybrid multi-cloud environments. So what about containers in that sort of world? Well, I feel like application containers are very often associated with the cloud. And actually in our research, when we asked our respondents, hey, where are you going to run your production application containers? They said, across our hybrid multi-clouds, in a combination of public clouds and private data centers. And that's because one of the value propositions of containers is just that. It's optionality, it's flexibility, it's portability. It's this notion of sort of like I write once, but I run anywhere. And because I can run anywhere, it gives me that optionality of choosing the best fit environment for what that particular application container does. For example, maybe I want access to a public cloud environment with different types of CPU, GPUs, and just super fast compute. Maybe I want access to an environment where I've got a managed container environment. Or maybe I want access to a content delivery network because that particular application container is the front end for my web app. Or maybe that application container is managing my data store. And I'm either in a regulated industry or I've just got a little bit more of a conservative security posture. And I want to keep that database, that data tier on-prem. Then I'm going to keep that tier of the application, that application container on-prem. So we absolutely see application containers being an entity that spans hybrid multi-clouds and in fact being portable across those environments. Now, Mukesh and I so far have really talked about the environment and really the infrastructure. And I love the fact that Mukesh made the point that it's really all about the applications. The underlying infrastructure at the end of the day is a delivery mechanism, to host and deliver production applications. And so we're going to move a little bit from sort of a horizontal view of infrastructure to a vertical view of cloud native applications. Now, I think a definition is in order. We hear this term cloud native in different contexts. And so we hear it with respect to companies, younger organizations that were born in the cloud that have never seen the inside of a data center, they're cloud native companies. We also hear about cloud native controls, that is the security controls that are provided natively by a cloud service provider. But in this context, really what I'm going to be talking about are cloud native applications, a definition of which has one part technology, one part process. So the way I think about cloud native applications, and this will frame up the next couple of slides, is really applications that are built on an elastic microservices-based architecture, but they're managed and delivered and secured via an agile DevOps process. So again, one dose technology, one dose process. And as I alluded to in the prior slide, or actually stated pretty explicitly, cloud native applications are not necessarily deployed and delivered from a public cloud. We're definitely seeing an increase in private clouds. Again, that optionality of containers being portable across hybrid multi-clouds is a great example. So again, continuing on this sort of vertical view of the application itself, cloud native apps are also heterogeneous. So just like the underlying infrastructure that they run on, the apps themselves are heterogeneous. Yes, we do have some respondents that say, hey, you know what, the cloud apps that I'm delivering now or plan to deliver here in the short term are exclusively container-based or VM-based or even serverless. But over a third said, actually, you know, they're a mix of VMs, containers, and serverless. It's a full stack. Sort of depends on the state of the code that you want. You might, you know, part of the code might be event-driven, so you're using function as a service. Some more persistence with serverless, and I mean with containers, and even more persistence with virtual machines. Now, let's connect some more dots in terms of that sentiment about increasing complexity with the challenges that are specific to those cloud native applications that I mentioned. First one is consistency. You know, I have to tell you, we've, you know, as a research organization, we've been conducting a lot of cloud security studies over the years, from cloud data security, cloud application security, hybrid infrastructure, cloud native applications. And the top challenge is always lack of consistency. How do I unify my policies across my disparate environments? So it doesn't matter if we're talking about how are you securing your data assets, or how are you securing your applications or your underlying infrastructure. Biggest issue is maintaining consistency across my hybrid clouds. And that is leading to the need, at least initially, for multiple controls that increase cost and complexity. Why is that? That's because there's a perception in the market today that environmental differences between these environments require different controls for these different environments. So again, this is the modality of starting off siloed, where you've got separate teams using separate controls for separate environments. And there are just too many specialized controls. It's absolutely driving point tool fatigue. Now, what happens over time is, as those new technologies, those new stacks, those new environments sort of gain critical mass, you know, they really become a really meaningful part of the overall compute environment, they do get mainstreamed, and that's really the catalyst for when organizations typically seek to unify their security postures across their disparate environments. And so that's, you know, one way to sort of frame up here how we move from the problem space that we've talked about so far today to really the solutions. And so in that same study, we asked our respondents, hey, what are your top priorities? You know, you shared with us a lot of your problems and challenges. Moving forward over the next 12 to 24 months, what are your top strategic priorities for securing a hybrid cloud environment? And these dots connect as well. You know, the first one is just all about automation. You know, today's world is about, you know, agile software development, which is iterative, where we're defining user stories in our sprints, typically a 2-week sprint. We're doing our daily stand-ups, and then, you know, we're implementing those user stories, which are a combination of, you know, software development and DevOps or infrastructure related user stories. And the DevOps as a cultural movement really has served to, you know, bring the IT ops and the dev team together, which has been tremendous. Now we're seeing security participate in DevOps, which is fantastic. So we can now start to incorporate security and really shift it left. And then we've got the CI/CD pipeline, you know, continuous everything, right? Continuous commit to your repo and pulls and builds and integration of your components and containers, and continuous delivery in an infrastructure. So it's a world of automation is where we're going here. And our respondents absolutely recognize that. And so a big priority for them is, I've got to automate all of the things, everything from the way I define what I'm going to build in Agile, my DevOps processes, and the way I continuously integrate and deliver my production applications. And that's one of the means to the other end, which is to build a cloud security strategy that spans their disparate infrastructure. You know, that covers the heterogeneous infrastructure, from private environments to, you know, customer managed colos, on-prem data centers, and all of their public clouds that they're being used. And so these are really dovetail, which is, part of having a strategy that spans these environments is to be able to scale vis-a-vis automation. Okay, so with all that said, and really sharing with you, some of the recent ESG research that's really relevant about some of the challenges, but also some of the solutions and how organizations, really your peers, are going to approach securing hybrid cloud environments. I want to offer an ESG point of view on the need for a cloud-native next-generation firewall. The first one is going back to the heterogeneous nature of hybrid multi-clouds, the mix of servers, and the composition of cloud-native applications. It's not that containers only talk to containers or cloud-native applications only talk to themselves. They absolutely make heterogeneous connections. I mentioned earlier that we still have Solaris running on, Oracle running on Solaris. So it very well could be that there's an application code running in a container that's making a connection to that stack running on a physical server. So this is just another way to think about sort of the heterogeneous mix of components that are running in today's world. It also means that while of course we want a microseg to implement least privilege as part of a zero trust strategy, that in addition to those access controls, we also still need to be doing content inspection between these tiers and between these disparate components of today's application stack and modern infrastructure. And so in addition to our ACLs that are having ports and protocols policies, we also want to make sure we don't have the lateral movement of threats, and we want to make sure we don't have any data being exfiltrated out of the environment. Secondly, there's this notion as of late, which I think is an awfully good thread to pull on here, of security being intrinsic, it being built in, it being sort of a fundamental characteristic of an application stack. And in order for security to be automated, it absolutely has to be. It has to be part of the design up front. But specifically when we think about containers and Kubernetes as now the de facto for how containers are orchestrated and automated, we need to be thinking about a cloud-native next-gen firewall as one that has tight integration with Kubernetes, so it understands those things that are specific to application containers. Simple things like names. We don't really use IP addresses, right, beyond the cluster itself. It's really the naming convention today is all about tags. Tags and namespaces really are the foundation of how we drive policy. So as we apply, next-gen firewalls to a containerized environment, to a cloud-native application stack, being tightly integrated with Kubernetes is important not only to automate the introduction of these controls every time a new container is instantiated, but also to make sure the right policy is automatically applied based on tags and namespaces. The other thing about being cloud-native is, it's not just for the applications, right? I mean, security controls themselves derive the same benefits from a cloud-native applications as the applications that they're charged with securing, namely elastic scale. So as your cloud-native apps scale up and scale down, a cloud-native implementation of a security control, i.e. of a next-gen firewall, also needs to scale up and scale down by similarly employing a microservices-based architecture. And finally, just to tie this all together, back to the main point that we're making today is, hey, most organizations, unless you're a cloud-native, newer organization, you're running in a hybrid multi-cloud reality. And so to be able to go from a siloed posture to a unified posture, you really need centralized management. Now, centralizing management also means distributed enforcement. So the idea is a cloud-delivered control plane that allows you to centrally define policy that can then be enforced at the appropriate control points, across your hybrid cloud environment. So Mukesh, with that, back over to you.
Thank you, Doug. That was very valuable, and it actually completely aligns with what we hear from our customers. So I wanted to take a minute to explain how the 3 layers of security that is used to protect the airports maps really nicely to the network security for hybrid cloud. At the airport, we install CCTV cameras so the security teams can see everything that's going on. In the network security world, those security cameras map to network visibility. It's ideal as a reactive detect and respond control, but it does not prevent the incidents. The second control is the boarding pass scanners at the gate. that maps to microsegmentation. It's an access control mechanism that is used to reduce your attack surface by limiting the east-west traffic to only what's essential for your apps to function. But boarding pass scanners alone aren't enough to prevent threats from getting into the airport. And that's why airport security uses full body and luggage scanners, aka TSA security check, and that maps to the next-gen firewalls. Just like TSA scans you and your luggage to ensure that you're not carrying guns and bombs inside, the next-gen firewalls scan the allowed traffic for threats and malware to prevent the attackers from breaking into your apps and exfiltrating critical data. You can use the same layered security approach to secure your hybrid cloud. Just like CCTV cameras are everywhere at the airport, you must have full network visibility into your environment. Then you deploy microsegmentation as close to the workloads as possible, just like the boarding pass scanners are at every gate. And that's why agent-based solutions for microsegmentation are a perfect fit. The third layer you need to protect your applications from threats and malware are the next-gen firewalls. And just like TSA check is deployed at strategic trust boundaries, there's one at the entrance at some airports, and there's one at each terminal, on some bigger airports. The next-gen firewalls need to be deployed at these trust boundaries in your hybrid cloud environment. All the traffic then that goes in and out of these trust boundaries can then be protected from threats and malware with full layer 7 protection. In the public clouds, the VPC or VNets tend to be these trust boundaries. In the Kubernetes environments, we are starting to see Kubernetes namespaces becoming these trust boundaries. We are extremely excited about these 70 plus new capabilities that the new PanOS release is bringing to make the world's best next-gen firewalls even better. I want to highlight just a few of them that are relevant to hybrid cloud security. The first one is CN series. As I explained earlier, as the risk and compliance needs of these container environments increase, the network security teams need the full layer 7 protection provided by the next-gen firewall for these environments as well. 4 years ago, we brought VM series to the public clouds to deliver consistent layer 7 protection for the apps running in public clouds. Now, we are bringing the same consistent layer 7 protection to the Kubernetes environments. So we are delighted to launch CN series, which is industry's first full next-gen firewall for Kubernetes. It brings the full layer 7 protection that our next-gen firewalls are known for: App ID, threat prevention, wildfire, URL filtering, DNS security at a pod level in Kubernetes. We are also bringing a brand new Kubernetes plugin to Panorama, which is our management platform. This plugin talks to the Kubernetes APIs and pulls all the Kubernetes metadata so you can write policies with it. This plugin can then not only program these context-aware policies to the CN series firewalls, but it can also apply the same policies to VM series as well as the hardware firewalls. So CN series and the Kubernetes plugin in Panorama will allow you to bring consistent layer 7 protection to your Kubernetes environments in both the public clouds as well as the private clouds. For your data centers, we continue to add more scale and performance at the highest end of our hardware platforms. With the new PanOS release, we are also launching a new data processing card, or DPC, for the PA7000 series. This DPC can add more CPU power to your existing firewalls and scale the App ID throughput to up to 700 gig. Last but not the least, we're bringing HA clustering feature that allows you to cluster up to 16 physical or VM series firewalls in the data centers for higher availability, capacity, and performance. With these new capabilities, you will be able to protect your smallest microservice running on Kubernetes to apps running on VMs in public clouds or private clouds, and the legacy systems running in the data centers, all with consistent layer 7 security managed centrally in Panorama. I hope you found this overview useful. Please join us in the next session, which is the part 2 of the hybrid cloud track, where we will go deeper into these new capabilities and how they can help you secure your hybrid cloud journey. Thank you.